So another approach that can be used to build the molecule in WebMO, right, is to go into the CSD and get yourself some type of template, right, that maybe has the same ligand or one that is at least somewhat similar. And then you can upload that, right, that transition metal complex that you then find in the web CSD, right, and then you'll just manipulate it a little bit to get it to be closer to what you want it to be and what you expect. So in this case right here, right, what I'm going to be looking at again is going to be one of the thiazole ligands. And so this one has now an enol off of it that I'm going to be checking out, right? So I'm going to throw in the nitrogens here for this guy. There's a double bond here. There's a double bond here. There's a carbon off there, right? And then here we have the enol, the oxygen, and this is a sulfur right here, right? So I have this, right? So I'm just going to simply choose substructure. Now, one thing to think about is that some of the ligands that we have, right, they don't have transition metal complexes necessarily on their own, so that those might be a little bit harder to find. But if you change around some of the atoms, or if you remove some of the structural components, you might start finding things that are kind of similar. Or one thing you can do too is this is a pretty okay-ish template overall, right? And you can just probably use this guy right here to start building off, your other ones. And I'll show that in a moment when I get to the WebMO, right, strategies to approach that part right there as well. But we have this guy right here. So if I do the substructure search, right, so I'm going to get a few different compounds, right? So this one, looking at it, kind of bananas, a lot of ruthenium, and is this cluster. That's not really going to be a good one. So if we go down a little bit, right, we look at this guy right here, we can see, okay, right, we have our ligand, it's bound to the rhenium, great, right, it has an oxygen and a chlorine off of that, that's very workable. And then over here, right, we see that there's a second ligand, right, so that's great because we have two of the ligands that we want and need. The only problem, hypothetically, right here is that instead of it binding through the ketone in this case right here, right, what it's binding through is through the nitrogen on this other part right there. And that could very well, right, be in reality what might happen with some of these ligands, is that they'll just, have weird binding modes. Well, not necessarily weird, right, but they're not, what we're predicting and trying to work on now. But again, everything's hypothetical, so that's just how things are going to be. But this is pretty good, right, because it has, the ligand has the backbone, so there's just going to be a little bit of manipulation that we'll need to do in this case to kind of get it to work and fit the way that we want it to work and fit. So what I'm going to do is I'm just going to go ahead and download then this file, right, so download the current entry, accept. I'm just going to wait it out a second. So one thing while it's downloading, apparently Mercury has been updated for Big Sur, and it seems to be working for people. So if you're on a Mac and you didn't download it, right, and you would just simply use the .mol files, right, in this case right here, right, you should be able to download Mercury now and manipulate stuff as needed be. I mean, all you're really using it for is just to generate the .mol file. So I'm going to open up the CIF in Mercury, right, because I'm not going to really do any manipulation because it just simply has the molecule in here that I want, and I can just do all the manipulation stuff directly in WebMO. So I'm going to take this, right, and then save as, right, desktop, and I'm just going to call this rhenium template for myself, right, .mol. So that should be set. So now we have this right here. So I can go into WebMO, right, import or create new job, file, import molecule, mol SDF, right, select the file. So what I want to do is go to my desktop and find the rhenium template, open, click OK, right? So now we have it in here, right? So we can look at it, pretty good starting point. So the big, things that are really going to be a problem that we have to kind of fix, right, is that, looking right here, we can see that, this nitrogen is the binding site to the transition metal at the center, whereas we want this oxygen to be that case. So what we can do is just simply delete that bond in that scenario right there, and then we can just simply do a quick rotation using the adjustment command. So, to make our lives a little bit easier, we can just simply look up what the dihedral angle is for, this carbon right here, or this dihedral right here, right? So this nitrogen, this carbon, this nitrogen, and this carbon has a dihedral angle of 15.590. So what we can do is just simply assign that to right here, right? So we're selecting those 4 carbons right there. And so we're going to change that to 15.590 in this case to 15.590. That should hopefully rotated that whole part of the molecule, right? But we got it there. And so, nicely, right, we can see that that oxygen's now in close proximity, so we can just build in that bond in this case. And so change tools to build, right? And then just set up that bond right there, right? So now we're set, right? So the ligand is built the way that we want it to be built, right? It's assigned and adjusted in this case, in those scenarios, just like that. So the only things we have left to do are to build in the acetonitrile and the SNO, right? So if I'm looking at what I want to build, right, I want to have the acetonitrile be trans to the oxygen in this case, and then have the SNO be trans to the SNO. So that means that this oxygen right here that I have selected, right, is I'm going to change that to the acetonitrile part. So let me just simply readjust my view of everything. And actually, let me just see if there's a way to quickly do this. Tools, build, calculate, cleanup. I'm trying to see if there's a template button, because I know there might be one somewhere. No, I'll look into it maybe, but it's fine. You don't really need to worry about it right now, right? So I'm going to take that nitrogen, or that oxygen, right? I'm going to turn that into nitrogen. Take the carbon here, right? Turn that into a carbon. Right, one thing, if you watch the other video, you can kind of see that you're going to have to do some adjusting here, right? That's a pretty extreme angle. And so, I mean, one thing you can do too, if you want to make your life a little bit easier in these cases, right, you can adjust that right there, click on adjust, change that bond angle, change that to 180. That should straighten it out. Another thing that you can then do is change these two and change that bond length. And so 3 is pretty extreme, right? If you change it to like 1.5, that should shorten it up right there, right, just like that. Right, and so it shouldn't look terrible in this case. And so, I can go ahead and go back to my build tool, right, and I can just add in, a triple bond in that case. And so then what I want to have now is then another carbon in this case. So we've got that. And so again, I can just simply straighten that out right here, right? Adjust the bond angle, change that up to 180, right? And then for that guy right there, right, what I can do is I can build in my hydrogen. So 1, right? So 1, 2, 3. So there's going to just be, made a double bond to that hydrogen. Weird. Right, so we have this right there, and so we just have to simply, adjust these guys a little bit, right? Clicking on them, using the tool, right? And then we can press T to do the translate button. And then we can just move things around, rotate stuff, kind of get them into position just as we want them to be. Right, so got these guys right there. It's all kind of planar. And so, right, I'm just going to adjust these guys a little bit, move things up, move things down. Right, it'll probably get fixed by the geometry optimization, right? And so the acetonitrile setup, in a good position. I mean, if you feel uncomfortable with how long those bond lengths are, right, you can just simply shorten those, right? Because we go to the adjust button and we just simply select them. And so one thing I want to point out is that when the first button, the first atom that you push is going to be the one that gets adjusted. So if we adjust this right here, so instead of it being not bond angle, sorry, bond length. Right, so instead of it being 1.5, like, right, let's say it's just 1.1. Hopefully, right, that'll pull everything closer and look a little bit more palatable, hopefully, for everyone. Right, so you have that right there. So that's done. Now the last thing we have to do is build out the SNO, right? So now we're going to replace that chlorine because that's going to be the one that's trans to that nitrogen. So we click on S here, right? So we've got that. And now we just need to build in the N and the O. So let's take the nitrogen here, right? Can build, I didn't want that to do any kind of bond there. Right, we have that nitrogen here now. Looking at it, right? You got that. Okay, cool. And then we have this oxygen, right? That's going to be slightly off there, right? Give it a double bond, right? And so we have, all of this right here. And so again, the sulfur, nitrogen, oxygen, they're kind of close right there. So if you want to, right, just for your own sake, you can click on the sulfur and the central atom here, and then adjust that and change that bond length, right? So let's just change that down to like 1.8 for now, right? So we change that down to 1.8, right? You can adjust the nitrogen sulfur distance right here, right? So adjust that guy to, right, so at 0.746, right? Let's change that to like 1.2 as well, right? In that case, and then we can do the same thing here, move out that oxygen a little bit to about 1.5 or so, or let's just do 1.2 as well. Right, so now we have it there, right? It looks okay. Things will get moved around and adjusted, but we have our molecule, right? So the molecule is built. The last thing that we probably should do, right, is change out what the central metal is from the rhenium to the iron, and so we're set, right? So we have a good start, looking at it, a good starting geometry, right? Everything is here, and hopefully everything should be able to easily position itself and maneuver itself in these cases. So the last thing that we would want to do, right, is when we go through and, we set up our geometry, right, we're going to be doing the whole thing where we're going to adding the new GTO commands. And so because there's, multiple sulfurs and nitrogens, but we're not looking to change all of them, it's going to be a bit tricky to figure out where each one is. And so an easy tool, or not tool, easy tip that I can give you is for the ones that are actually bound to the central atom that you want to change, right, is to actually change them to atoms that are not the ones that they actually are. What I mean by that, right, so all of the nitrogens that are attached directly to the iron, right, the ones that I want to add that keyword to, I can go here to the periodic table, right, directly below the nitrogen is phosphorus. I don't have any phosphoruses in here, but I can click on all of these, turn them all into phosphoruses for now. Same thing I can do with the oxygens, right? So under oxygen, right, we have, well, there's sulfur. That's not really going to necessarily be the most helpful in this case, right? But we can click, fluorine, right? So if we change all of those to fluorines that we care about in those cases, right? And we just have to keep, a mental note of which ones we're changing. So then for the sulfurs, right, we change those to selenium in this case, right? That's bound to it. So now all of those are changed right here. I forgot to change one of the nitrogens, right? The one that's on the SNO as well, right? So we have all of those changed right there. So now when we set up our computation, right, we can go here. And so, iron, what is this right here? NO, SNO in this case. So molecular, geometry optimization, B3 lip, B3 lip, def2 SVP, def2 TZVP/C. In this case right here, right, we're going to have a charge of -1, right, because there's 3 anionic ligands total and then a 2+. So that's going to be then for the multiplicity is going to be a quintet, unrestricted checked, advanced, RIJ COSEX cores 32, right? So we have that. Now we click on the preview, we generate the preview, we have all of this right here. So now all we have to do, right? And so one thing I also like to do, just as a simple tip, is you can go in and, from your old commands, right, that you have from the ruthenium computation, right, you can just simply copy that and paste that into here, right? So we have this right here, delete this part out, right? So now I have this command here. So you don't have to retype it. It should hopefully have the correct formatting, right? Especially if you were running into that problem with the whole, curly quotation marks and stuff, you don't have to worry about that. So now I can just start throwing this in there. So now I just go through and I look for all of the, altered atoms that I have, right? So everything that's selenium, I know is going to be a sulfur. So I can change that selenium into a sulfur, change that to that, right? Anything that's a phosphorus, right? That becomes a nitrogen. And so then I just simply add the key there, right? Everything that's a fluorine is actually an oxygen. Change that right there. Go through, right? So this is a phosphorus, becomes a nitrogen. And then scrolling through, right, we have a fluorine right here, that becomes an oxygen. Scrolling some more, sulfur, here's a phosphorus, right, that becomes a nitrogen. Here's another phosphorus, right, that becomes a nitrogen. And then here's a fluorine right here, that becomes an oxygen, right? So going through it, right, there should be a total, in this scenario of, let me do the counting up real quick. There should be a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 atoms that have the new GTO command, right? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have all of them set. They should all be changed, right? Let me just double check, right? That I don't have any phosphoruses or fluorines or selenium just hanging out in these cases, just ready to wreak havoc, right? So all that's set. So now the input's all done, right? You can copy that using the text editor into your file, right? Make the .inp file and then submit that right through the CCV to run the geometry optimization. Now, if you've gotten this far, right? So that's what you do there. So let's say hypothetically you're not doing the enol in this case, right? What you're doing is a different one, right? So let's say you're doing the one that has the thione, right? So I did that one in a different video. You can adjust things here to make that one work as well. Right? So, you know, the general framework is pretty similar, right? You have the thio benzol there, right? And so same thing too, right? If you're having the nitrogen or if you're having the sulfur binding from the benzothiazole rather than the nitrogen, right? All you have to do is just simply change these things around. So if I go back, you know, and readjust everything, in these cases back to what their original atoms were, right? So this becomes a sulfur. This is a nitrogen, 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 oxygen, 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 right? So all of this right here is all set up. And so now if we want to, you know, let's say hypothetically we have, instead of it being the nitrogen from the benzothiazole that's binding, right, it's actually the sulfur. All we have to do, right, is we can just simply turn this into a nitrogen, turn this into a sulfur, right? And that'll fix itself, right? Same thing over here. Turn that into a sulfur, turn this into a nitrogen, right? So that's a very easy, quick way to fix it, right? And the bond angles and all that stuff is going to get adjusted during the geometry optimization. Same thing, right? If we're adjusting the 5-member group that's over here to something else, right? Either we can just start deleting atoms that we have in these cases, or we can just start, you know, adding atoms to it, right? So in this scenario right here, right, this becomes the thione, right? So that salt, you know, that oxygen becomes a sulfur. So let me just change that into a sulfur for now. Same thing over here, that becomes a sulfur as well. Right, so that's done, you know, changing up where the nitrogens are, right? So this is a nitrogen in the other one. And then this right here is a nitrogen over here as well. And so the next thing that we're going to do is convert this nitrogen back into a carbon, and then let me just look at it properly. And then this nitrogen right here back into a carbon, right? So now we have, you know, our imidazole ring. So this guy right here needs to be adjusted, right? So that should just simply become a hydrogen now, right? And then I have a hydrogen that binds off of this guy right here too. And then, right, we'd have hydrogen with 3 other hydrogens bound to it, right? So we can just delete those guys off of there, right? So that's taken care of. And something got messed up. Because I still had those nitrogen oxygen set right there, right? So I don't want those set, so I'm just going to click on them to remove them. So now when I delete it, it should only be deleting those guys right there. So one thing too, right, is by adding that hydrogen in, this guy is like way out here. And so hit the T. Right, so that's that, right, probably want to bring in this guy a little bit too, because that hydrogen's pretty far out there, right, so just bring that in a little bit. Right, so that guy's set, and so now I just need to simply add the CH3 group right there, so that becomes a carbon, and then I just simply build the hydrogens off of it. Right, so that guy's done. And so you can then, you know, do the same thing for the other one. I'm not going to go through that right now. Right, and then build it up so that it looks like the ligand that you want to be in those cases, right? And so that's, you know, how you can use crystal structures, and even crystal structures that aren't necessarily for your, actual complex or ligand to do these things. So, yeah, hopefully this was helpful and you guys can, you know, chug away. All right.